Hello, this is Mr. Mormon. Welcome to Lesson 2 in the Nature of Science. Today we're going to be talking about the scientific method. Make sure you copy these notes into the notes section that you've started already and make sure there's a good heading on it. Let's start with, we're going to do an overview and then we're going to focus a little bit on hypothesis. Okay, so first a definition. The scientific method is a series of steps used to investigate and answer questions and solve problems. I break the scientific method down into 7 steps. First, you're going to identify the problem or question. Then you're going to do your research. Head to the library. Look for books, magazines, newspapers, any information you can get. The internet is also a great source of information when you're doing research. You can also ask an expert. Once you've found out everything you can about the problem, it's time to make your hypothesis. Many students have learned that a hypothesis is an educated guess. I like to think of it as the answer to the question or the problem that you're trying to solve. That's your hypothesis, what you think the answer to the problem is. Next comes experimenting. You'll have to plan your experiment. Often this is called the procedure. Once you've got a good plan, then you actually perform the experiment. You're going to test your hypothesis. As you perform the experiment, you will be collecting and recording data. First, your data may go into a data table, just making a list of everything that you observe, but afterwards, very often, we will put that data into a graph, usually line graphs in science, so that we can better understand the data, look for trends, be able to make predictions. Then finally, you're going to analyze your data and come to a conclusion. In your conclusion, you're always going to be answering the same question. Does my data support my hypothesis? Here's a nice flow diagram I found on the internet that helps explain the scientific method. The source is at the bottom. If you look at the top, you see the scientist has identified the problem. From there, you do your research. I would probably put that step in there. Of course, you're going to do research before you decide what you think the answer is. You'll then make observations, perform an experiment, test it, organize and analyze your data. And if you're right, then you would move on to, if the data does support your hypothesis, then you can write up the experiment that way. If your data does not support your hypothesis, that's the sad scientist right here, there might be a problem with your experiment, or maybe your hypothesis was incorrect and you have to go back and do a new experiment and then follow through with these last steps. You would then draw your conclusion, answer the question, does my data support my hypothesis, and then you publish your results. Remember, we talked about how important communication is in science. You need to spread what you have learned to allow other scientists to learn from your work. Now, I just want to talk a little bit about this guy who got it wrong. His hypothesis was not correct. That doesn't make him a bad scientist. Remember, we're trying to get to the truth. And when if your hypothesis is incorrect, but you do good experiments and find out that your hypothesis is incorrect, you're still a good scientist. You're now even closer to the truth. You know what is not the answer. And when you disprove a hypothesis, it gets you closer to the truth, which is our goal in science. Now, I want to talk a little bit more specifically about hypotheses. Hypotheses should not be written as a question. A hypothesis is an answer to a question. It's what you think the answer to the question or the problem is, so they should not look like questions. Very often, hypotheses are going to be written in the if-then form. In other words, you'll write the hypothesis starting with if. You'll then state the factor that is being studied, then, and you will suggest a possible result. If, then. You can often add because after the if-then statement and give a reason why you think this will happen. Sometimes it won't be possible to form your hypothesis as in an if-then statement, but it's very often that's what we're going to be using. But it's not an absolute. They don't always have to be an if-then. Okay, let's do some practice. Let's put this new knowledge to the test. These are the posters I have in my classroom. Each one identifies a different part of the scientific method. Could you put them in order? What would come first? That's right. You're going to think of an idea. It's going to be a question or a problem that you're going to try to solve. Okay, what next? Right. Research. Okay, after you've gone to the library, gone online, asked an expert, what next? Of course, you're going to make you're going to form a hypothesis, what you think the answer to the question is, or the problem. So now you've got your hypothesis, what next? Right, you've got to test that hypothesis. You need to experiment, but first, you need a plan. You're going to plan your experiment and make a procedure. Next, of course, is the experiment itself. When you're doing the experiment, this is getting easier, there's only a couple left. When you're doing the experiment, you're going to be collecting and recording data. After you analyze that data, you then have to come to your conclusion. I hope I can squeeze this guy in here. Yeah, there we go. And remember, in your conclusion, you'll be answering the question, does my data support my hypothesis? Okay, I think that's enough for today. Tomorrow, when you come to class, be ready to discuss the scientific method. Maybe make a list of the steps in the scientific method, put them in order. Maybe we'll work a little bit with the posters.